So, what's the thing called the synapse? It's a gap, right? Message comes through the axonic fibers. Now it's waiting over here. The dendrites are waiting over here, and it's like, well, wait a minute. We got this space. How can this message that's traveling along? For example, let's say someone bit you on the finger, right? So now this message is coming through the finger all the way up through your arm, spinal cord, and boom, hit your brain, right? Well, how does it get there, right? And so, especially when we have all these gaps in this, this wire that's supposed to be this neuron that's making this message go from point A to point B, right? And so what we find is that in the axonic fibers, there is a buildup of a chemical. And this chemical, acetylcholine is an example of one of them. This chemical then causes an electric spark, if you will, if there's enough buildup, and the spark then jumps over that gap, goes on to the next set of dendrites through the cell body into the axon, jumping again the synaptic gap and going then quickly to the brain, depending upon how significant the stimulus is. So if someone just bit on your finger a little bit, the message may not travel as fast. But if someone just took a big bite, your sister grabbed a hold of your finger and just took a big bite of it. It's like, ow, right? And we want that message to go quickly. Why? So you can get your finger out of your sister's mouth, right? And so that's why some messages in our body will go quickly and others will take some time to do it. Got it? So what do we got again? We got messages coming in to the dendrites, through the cell body, through the axon, jumping that synaptic gap, continuing on through the dendrites, cell body, axon, synaptic gap, and so on till the message receives its final destination. Make sense? Okay.